Good morning. Last time we were doing the solving absolute value related inequalities here. Do you have any questions? I believe we did a 15, alpha 15. How did the quiz go? Do you have any questions, Francisco? Do you guys have any questions? Good morning, Alan, Brianna, Francisco, Zapatra. No questions? All right. We mainly talk about, there are two major types. One is absolute value less than a positive number, absolute value greater than a positive number. Sometimes we have greater than negative number, greater than or equal to 0, or all of, these other cases. Okay, these other cases. And do you guys have any questions up to 15, alpha 15? If you don't have any questions up to alpha 15, I will take you guys to alpha 16a. Okay, so let's look at alpha 16a. Alpha 16a should be in the notes on page number 16. Okay, let's look at some of these questions. Okay, Okay, let me make these fonts just a little bit larger. Would this be better? Are these fonts better in terms of size and clarity? Hello. Okay. Now, look at the first one. Okay, look at the first one. The first one, we're solving an inequality that is look like this: absolute value of 5x less than 20. I want to show you a couple of different ways we can approach this. Approach this question. One way is that you go straightforward, just like absolute value of x less than 3. Okay, then you go straight to then 5x is larger than negative 20, greater than negative 20, less than 20. Okay, so when you read this, you will read it as if this is true, then that is true. And if this is true, we're going to divide every side by 5, and we will get a negative 4 less than x less than positive 4. And then you're done, right? If this, then that. And if this, then that. It's done. Another way to do this is that you can actually take the 5. Okay, you can actually take the 5. If this is true, you can take the 5 out of the absolute value, because 5 is a positive number. So when you take 5 out of the absolute value sign, you will get a 5 multiply absolute value of x. And that's less than 20. And then you can divide both sides by 5. Okay, we can divide both sides by 5, and we end up less than 4. Absolute value of x less than 4. You can do this. Yes, you can do this. Okay, and of course, in the end, you still get the same answer. And that's done. Okay. So we can take the constant outside the absolute value, and of course, they will show up as a positive number. because the absolute value of positive number is the same as the number, right? But anyway, number 2 would be similar. Would you like to try number 2? Would you like to try number 2? Either way, and maybe you want to try both ways. Did you finish? Are you done with number? Are you done? Here I'm just summarizing these cases. Okay. Well, one of these cases would be, I turn into. Well, I can actually just, for simplicity, I can use 3. I can use 3. Okay, I can use 3. Of course, I can use 1, but that's going to involve some changes. Okay, so to save time, I'm just going to summarize these 3 cases. These 3 basic cases. Are there variations? Of course. Okay, there are variations. Okay, so this will be the interval form, and that one over here. So these are the basic forms. Okay, less than 3, larger than 3. And what happened to equal to 3? Equal to 3, we definitely have seen some stuff, but I'm going to modify this picture. In other words, you just have 2 dots. Okay, equal to 3. So I'm going to have this one, and that's going to be a dot, and that's going to be a dot. And I no longer have these. I no longer have that. Equals to 3. So for equals to 3, and for the number line, okay, so I'm going to bring up this summary here. Okay, number line. Okay, that's a number line. And with equals to 3, I'm going to just quickly work out these, just give you the visuals as a summary. dot dot gone dot. I'm going to justify this. I'm going to make some adjustment to these scales. -4 to 4. And this will mean look the, you know, these scales are more comparable. Even though it doesn't matter in either way, they're good. I just want you to have some kind of visual, so you can see these three cases: less than, equal, greater, and the most important part is the algebraic expression in inequalities: less than, equal, greater. Okay, and these are the forms we're looking for. These are the form we're looking for. Visually, you have these, you have these visuals. Okay, we have these visuals. And in this particular case, right, number 2, in this particular case, we have a 16x. Okay, we have a 16x less than or equal to 8, right? So it's really these two forms together, these two forms, less than or equal to 8, not less than or equal to 3. So it's these two forms combined, these two forms combined. These two forms combined, of course, it's just a matter of combining these two, combining these two, you will end up with -8 less than equals to 16x and less than equals to +8. And then you divide every side by 18, by 16, you have a -12. Less than equals to x and less than equals to +12. Okay, less than equals to, this is the absolute value, less than equals to 8. Of course, you can do the other way. Okay, you can do it like that, divide both sides by 16. You certainly can do that. So either way works, but primarily, you can see that these three cases we have, these three major cases, I'm not excluding other cases too, okay? There are other cases, okay, special cases. So here we can divide both sides by 16. 16 can be taken out. And that's less than equals to 8. Of course, you guys probably already know that, but I just want to show it for the record. And this is less than equals to half. And then in the end, you get the same answer. You get the same answer. Okay, so all of these questions, they fall into either one or two of the cases. Okay, this is the function perspective. And this is the number line perspective. Okay, so let me make a little adjustment over here. Okay, because the scale is just a little bit awkward here. Okay. There. Make it -4 to 4. I just changed the view a little bit. Okay, I just changed the view. Anyway, so that is done. Okay, so next I want you guys to pick up 3 questions. 3 questions, okay, from 16A, from 16A. Okay. So please pick 3 questions. Okay, so please pick 3 questions. Hard questions for you. Okay, if they look hard to you, that's good enough. Hard questions, arbitrarily. Okay, you can pick any 3 questions arbitrarily and work on them. And then ask questions. Ask questions. In 16A, of course. Alpha 16A. In alpha 16A. Okay. Good morning, Francisco. I see your message. Thank you. I'm sorry, I just opened the chat. Just opened the chat. Okay, if you have any questions, please don't hesitate to post it at chat, either public or private. Either public or private. It looks like the sun is out, isn't it? How's it going? Ignore what I'm doing, okay? I'm just getting ready for this picture. How's it going, guys? You done? Yeah, pick you three. You think you can do all of them? Yeah. Good. Take your time. Take your time. I'll be checking your quiz today. and get back to you. You can start to bring your questions if you want. Okay, I'm here. You can post your question at chat. Where did my chat go? Let's see, reaction. Chat. Where did my chat go? That's really strange. I couldn't see my chat. Oh, okay. Hold on.
Professor,
Yes.
for number 4, I'm having trouble with it. I got lost. I don't understand if it's I don't know if the if the answer is x greater than equal to 0.5.
Well, in this case, you can multiply 2 on both sides, can you?
Oh,
Right? Don't worry, we'll have all of your issues resolved. I'm trying to find my chat. Anybody posted anything on chat? Oh, where's my chat? Okay. Oh, there. There. Sorry. It's I found it. Okay, so maybe we start with 4. Are you still solving? These questions look a little bit not as tidy, right? They don't look as tidy as the ones we have in the table. But no fear, okay? I want you to show you the perspective. Okay, so here you have a 1/2, and then multiply absolute value of x greater than equals to 1. Okay, which type does this fall into? Obviously, you have a greater than, equal, so it's going to be this type. But the outside the absolute value, there's a number. Okay, what can we do about it? Well, what we can do is that if this is true, okay, we can multiply both sides by 2. If this is true, and multiply both sides by 2 will still be true. Right? So you will get absolute value of x greater than or equals to 2. This step, it really is optional, but it shows you how to get there, okay? And so your answer will be, will be the combination of these two, and it's going to be for 2. right? So it's going to be these two cases. It's going to be these two cases, except, okay, instead of it's 2. You know what I mean? And just these numbers will change to 2. All of these numbers will change to 2. Do you guys follow me? That's what I meant. They're the same types. They're the same types. Okay. And of course, I need to make some adjustment for these. And of course, that's going to take a little bit time. Okay. But if I got the time, so this is going to be 2. And this is going to be 2. And there. And then I need to remove those 3s.
Professor,
Yes.
where's the 2 come from?
The 2 come from, I multiply inequality number 4, multiply both sides by 2.
Oh, okay, thank you.
See that? Okay, you can see that the change is minor. The change is minor. I'm just making those changes for you to see. Do you guys see that? The visual, the meaning. Wow, this is gonna be 2. This is gonna be 2. Yeah, right. So that's you see we make that adjustment just to okay, do you guys see that? And of course I could have made the same adjustment over here. Do you see the similarity? So there's a little bit of algebraic manipulation here. There's some algebraic manipulation there. But other than that, there are similar questions. Do you see that? Do you?
Yes.
Okay, so we see that. So that's what I want you to see. And these two cases combined. These two cases combined. Okay, just allow me to make that adjustment. So hopefully I don't confuse you in any way. Right, so these two cases combined, that's greater than equals 2. As far as that, you know, when you multiply or divide in front of absolute value, you can take that number, do the manipulation, like multiply, divide. We did divide in number 1, number 2, right? So number 4, we multiply. Can we separate the addition? No, we cannot separate the addition. We cannot separate the addition. Okay, so that was number 4. Next question from you. Next question from you. Questions, plural. Okay.
Can we solve number 3? I just want to know if I got that one right.
Okay, number 3. Two x absolute value greater than 7, right? So in this case, it's really just this type. It's really just this type. You don't really need to show the picture to me. because you're not getting credit for it anyway. But you need to have that picture in your head. Since you are going to have that picture in your head, and if you want to draw it on your paper, when I ask you to write it down, yes, you can. But make sure it's well organized, but don't expect any points, because you will get points for the correct inequalities, like I have illustrated before. Okay, but you have these pictures in your head. Okay, so instead of, so omega here is 2x, and this 7 replaces 3. So the picture is going to be the same. The picture is going to be the same, except these points are changed. These points are changed. Okay, so I'm going to change the points for you as we go for it. Okay, there are 2 ways to do it. Okay, you can take the 2 out, absolute value of x greater than 7. And then you're going to have absolute value of x larger than 7/2. I don't care about a mixed number or decimal, I prefer fraction, okay? We all of our students are not a favorable of fraction. That means you need practice with fraction, right? So just do fraction, use fraction, okay? Have some more, build your number sense about fraction. And then this piece is similar to that. You see that? So the x is omega, and 7/2 is 3 in this scenario. So in this case, it's just 7/2. It's just 7/2. Do you follow me?
Yeah.
Okay, you're going to adjust your picture. You're going to adjust the picture, but what's the answer? What the answer will get you the point? The answer get you a point would be this one. 3 points. You understand the picture. You need to understand the picture. Okay, do we understand the picture? Do I need to explain it? Don't hesitate. Then you just have to make some adjustment. This -3 turn into -7/2. This 3 turn into 7/2. And you make those adjustments. Okay, and the part of work you need to show, really, the part of work you really need to show. Okay, I would say this step is optional. Whether you show me or not, it doesn't bother me. It's not going to lose your point. If this is the approach you work, then it's just line number 1, line number 2, line number 3, 3 lines, you're done. Picture is optional. Picture is optional, but I always attach to it because I want to illustrate. I'm illustrating these, the meanings and so on and so forth, right? So here I'm going to make some, I'm going to make some adjustment. Okay, so it's going to be 7/2. You see, I'm going to change all the 7s, all the 3 to 7/2. Okay. 7/2. 7/2. And let's see, do we have more? Yes, 7/2. More. Just change. Just all these changes. Do you guys follow me? Is this hard to you? Right? I'm going to remove those 3s. Just remove it. I'm just going to remove them. Okay, if you like, you can mark these 2 points. You can mark these 2 points. Okay, and these will be these can be adjusted accordingly. Okay, these can be adjusted accordingly. Is that clear to everybody? right? So you understand the picture, how it works. There's a function perspective, there's a number line perspective. And once you understand this picture, understand how algebraically we express it, how graphically we demonstrate it, right? So you're good. You're good. Okay, and of course I can hardly wait to see your quiz. How did you do? How did you do? Ah, okay, gotta make adjustments somewhere. Okay, so I need to make this adjustment. But anyway, you can see it takes some time for me to make that adjustment, but everything is just very similar. Okay, so go on with your questions, please. Go on with your questions. What does the symbol mean in the absolute value? It means bacon. I like that. I heard about this first time. Could you illustrate that? Marilyn, what is bacon? Yummy. What does the symbol mean in the absolute value? Which symbol? The two bars?
No, I think he's talking about omega.
Oh, omega. Omega is just, I call it bologna. You can think of as bacon.
Oh, I thought it was bacon. I'm over here thinking it was bacon, not bologna.
Oh, the horseshoe look like in what? It's just a symbol. Okay, it's just a symbol. The symbol here in this case is X, right? You take this one, right, put it right above it. Okay, this X now is omega. It's read as omega. Can you say that? What I meant, it's just any symbol. I can put a heart there, can I? I can put a heart there. Could I? Oh, I can. I can put any symbol I want. It's a placeholder. It's a placeholder. It could be any number. You don't plug in. You don't plug in, okay? It's just a symbol. The symbol represents any number. It represents any number. Do you follow me? But we want those, but this, when we plug in any number, we want the consequence within the output to be less than 7/2 in this case, okay? For example, I really can use any symbol. I can use spade if you want, right? I can use any symbol. It is a placeholder. If you really want to ask what that is, it's a placeholder. Okay, I really can put any symbols. Okay, what else symbol can I use? I can put a Q there, right? I can put a, what else symbol sounds interesting to you? Diamond. It's a placeholder. It represents numbers. And this whole statement says the absolute value of a number is larger than 7/2. But I also have other reasons to put this omega here instead of X, because look at your following example. Say number 5. Number 5. Number 5, we're solving this inequality. We have it, it's called x minus 4 less than equals to 3. And what is the omega? Less than equals to 3. In this case, if you think out aloud, okay, I treat this as a piece of scratch paper. my omega is x minus 4. This is my omega. Do you see that? Do you follow me?
Yes.
This is my omega. So omega is a placeholder. It could be complicated. It could be a more complicated expression than what we saw as x, y, z, whatever. It could be a more complicated expression. So omega represent all of those complications. Does it make sense now? And in this particular case, it's x minus 4. Okay, so in our mind, you have these two cases. Okay, so you're gonna work with omega. Okay, you first work with omega in your mind, right? So this is gonna be -3 less than equals to omega and less than equals to 3. And then you're gonna put you're putting your omega x minus 4 back into the play. So this is gonna be x minus 4. Do you follow me? Symbolic operation. And then of course our final goal is to isolate the x. So we're gonna isolate the x by adding 4 on every side. Okay, so we are to isolate x. So we're gonna add 4 here, add 4 here, add 4 here. The rationale is if this is true, then this is true. If this is true, then that is true. And finally, we're gonna get a 1 less than equals to x and less than equals to 7. And that's the role of omega. Is you see it as blurry. It's just a placeholder, and that place could be occupied by x minus 4. Make sense? So that's the role of omega. And yeah, you can definitely think of as a bacon. Whatever is your favorite food. What is your favorite food? Bacon? Cereal? What else? Donut?
Cocoa Puffs.
Yeah. Popcorn? It's just a symbol. It's the meaning of the symbol that matters, right? The symbol itself doesn't matter. You can use any symbol, but it's the meaning of the symbol that matters. Okay, you can use that symbol to represent a lot of things. Right? You can think of this as burritos. I love burritos. Or fish taco. Think of this as fish taco. Okay, this is fish taco. I love fish taco, right? And what else you can think of? Really, any symbol that makes, but that symbol has a meaning. Okay, that symbol in this place, in the context of mathematics, it represents numbers. It represents numbers. Okay, it represents numbers such that this statement is true. That's what it is. That's what it is. Excuse me. Okay. So go on with more questions. Come on, guys. So these pictures, you don't need to show me these pictures, but it's optional. Even though it's optional, but you need to have that picture in your head. You need to have that picture in your head. The reason I use omega because most people just use XYZ, so the omega will not be confused with XYZ. Okay, I don't want to use the same symbol in the question, so it doesn't confuse. So it could represent but not confuse. Okay, so that's number 5. I'm waiting for more questions because I do expect some more questions. So there's some more interesting questions as we move forward. Okay. Next question.
Can we do number 7?
Of course, number 7. Look at number 7. Less than 0. Absolute value of something less than 0. So what is omega in our case? What is omega in our case? What is omega in our case?
It would be the fraction, right?
Right here. What is omega? Sorry, I'm sorry. Okay. If you think out aloud, you try to make sense out of this question, you have a number here. So you can think of this as a number, right? Yes?
Yes.
Of course, that number is that fraction form. 7x minus 5 over 3, right? So you think of this as omega. And you want the absolute value of a number to be less than 0. So that's a question. This question is, if the absolute value of a number, that number takes whatever form, that number is going to make the absolute, that number you put in there, absolute value of that number is going to be less than 0. Is that possible? It's impossible, no solution, isn't it? This thing putting inside there is just a number. Don't need to be worried about its form. Whatever form it is going to come out as a number. So let me show you the process this is going to be. Okay, if you really want to see, that's a fraction and so on and so forth, think of this way. This number is the input. Okay, it comes here. And it gives going to give you an output. It's an output. It's a number. Okay, and then this number is continue to be taken absolute value. Okay, whatever this number is, this output will be taken as absolute value. It's going to come out. And you want that output to be less than 0. You either see this as this process, okay, you want the output to be negative, or you just see it as blindly, this is just omega. And you want the absolute value of a number negative to be negative. That's impossible, therefore there's no solution. Do you follow me? Does that make sense? Does that make sense? Everybody?
Yes.
right? Any questions? So please post your question if you do have one. So how to answer this question? Okay, all of these are you thinking out aloud. However, you look at that form, then it's impossible, right? Because no matter what number you plug in here, the output can never possibly be what? Negative, isn't it? Because after you take absolute value of any number, if this is any number, the output, it could be any number comes out. You take absolute value of that any number is always going to be greater than or equal to 0. So that is impossible. Make sense? And thus no solution, because no matter what the input is, it will never be the required output. It will never happen. Okay, so what do you say? No solution, because the absolute value of anything is greater than equal to 0. We all understand this, don't we? Do we understand that? Do we understand this statement? Remember, I emphasized this statement earlier on, didn't I? Did I emphasize this statement earlier on? What is the implication? What is that anything means? This is just a placeholder. If you replace it by omega, it's going to be true as well. Of course, if you replace it by this guy, it's going to be true as well. Do you follow me? That's anything. It could be this thing, it could be another thing you invented, right? And you see this example on number 11, number 12, don't you? What is anything? What is anything to us? Tell me. It could be, it could assume the form of x, it could assume the form of this fraction form. That's anything. Do you follow me?
Yes.
The absolute value of anything is always greater than equal to 0. Therefore, that absolute value less than 0 of anything, the absolute value of anything less than 0 is never going to happen. You follow me? It's just a camouflage. It's a camouflage on anything. Got it? So that answers question on number 11 and 12. How about number 8? How about number 8? I want you to think about number 8. Use your common sense, okay? There's no mystery to it. There's no mystery to it. Once you understand absolute value, you understand what I meant. And now I hope you really understand what this means. Okay, this is the one single reason. This is one single reason to tell you the answers about the answers on number 7, number 11, number 12, and now it's number 8. Okay, so please everybody work on number 8. Okay, we certainly didn't have that form here. Right? If you're familiar with these forms, right? You have a 0. And all these three forms, they give you the positive numbers. If you try to make it into this form, you could, but usually it's very awkward. It's unnecessary. You follow me? It's awkward and necessary. This is the time we need to put on our thinking cap. Okay, this is the time we need to put on our thinking cap. Okay, so if you think out loud, and you're gonna get into one of these forms, usually the work I see from the past student in the past, they're awkward, they're a mess. Very few of them show them very nicely. But by the time you really understand, you don't really need to do that. Okay, so let me show you. If you use any one of these forms, it's not going to get you very good, nice answers, because you probably will confuse yourself. I don't know what you've done there. If you want to show your work for the moment, right now, if you can upload and message me from Pronto. I prefer you send it to me from Pronto unless you really, really don't want your classmates to see or know who sent it. Because from Pronto, I can upload to the classroom really easily. Okay, for text message, I have to take a detour. Okay, I still have to go through Pronto to attach that picture. So right now, I want you to think from this perspective and that. And of course, you have this picture I was promoting here. You can do any work you want, and so I will give you, I will give you the feedback you needed, and then I will show you how to show work here. Okay, so it's absolutely worth our while to spend time here. So don't worry about it. Your question is important. Your questions is important. Okay, did you work it out? Just take your time. Take your time. Okay, and I'm gonna bring up the Pronto. Pronto or chat, upload. You can even send it to the inbox, but I don't think that's necessary. You just use your cell phone. That will make it. We need to think. Okay, so now we understand what is anything. The absolute value of anything is at least 0. And this expression, we want the absolute value to be less than or equal to 0. What? Okay, there's all these things you are in this classes, we've been covering all these things. Which do you think will be relevant for your answer? How would you do your work? And what to think about? Don't worry, I'm holding your hands to do this, okay? Don't worry, even if you make a mistake, no big deal, right? This is not a test. You know what I noticed? I noticed only 5 people submitted your work. Only 5 people submitted your work. Wonder what's going on. Okay, are you ready to send me your work? If you don't want to, then that's fine too. Don't feel embarrassed, okay? Don't feel embarrassed. We're only judging your work, we're not judging you. Oh, excuse me. So what we get? What do you think? Are you still working on it? You guys still working on it? Anybody want to show your work? Or no one want to show your work? Anyways, fine. I will show you. I will show you how to go through this. But I really want to see. Maybe we have some of those stuff, and everybody could benefit. Are you ready for me? Are you ready for me? We're going to take a break after this. Okay, we're going to take a break after this. Hello? Are you ready for me?
Yes. Yes.
Okay. I'm going to type. I will type. Okay. I hope you write it down. I hope you write it down. I view this, okay, as omega. But you can leave it as it is. Okay. You don't have to do that. This means, okay, absolute value is less than 0. Or, so first we need to understand what it means, don't we? Equal to 0, right? Less than or equal to 0. That means this means absolute value omega is less than 0 or equal to 0. That's what it means. This is impossible. It's impossible. Right? Thus, so if this is true, then this must be true. If any omega make less than or equal to true, less than or equal to 0 true, and this must be true because this other case is impossible. Does that make sense? And
Yeah.
if this is true, then omega must be 0. Do you follow me? Because only the absolute value of 0 is 0. Yes? Right? Do you follow me? And now this omega is, oh, hold on. This omega is this guy. Do you guys follow me? That's one of the cases of omega. That's one of the anything. Anything. This is one of the anythings. Does anything has plural? Did I just say anythings? Forgive my Chinglish. That's the anything. That's the rationale. Do you follow me? I should have the omega part over there. Okay, so think about it. I want you to follow these logic. Okay. Think of omega just a number. It's just a number. It's an output. It's an output. It's an output after taking absolute. There's an output after you take an absolute value. And omega and x is just the input. Okay, so once again, you think of this as x is the input, I give it to this guy. Okay, and this guy is that guy. It comes out and I give it to absolute value. Of that omega, you can call it omega. It comes out. You want the output to be negative or 0. And then you are told, hey, negative is impossible. You only have one possible output if that's what you want. If this is what you want, this is never going to happen. You only have, only this can happen. Does that make sense? Does that make sense, you guys? That's what it is. Okay, so how do we put the work together? How do we put the work together? With all these thoughts in your mind, all these thoughts, does everybody understand what I'm talking about here? You need to have these thoughts go through your head, not just memorizing a few steps. If you rely on memorizing 3 steps, 5 steps, okay, after 10 questions, you'll be completely confused. Do you agree with me? Suppose every question you work with, you're working with 10 questions, okay? 10 questions. Every question just have 3 steps to remember. Oh, that's not too much to remember each question, right? But you have 10 questions. And 10 questions, each question has 3 steps. That's 30 steps, right? And different scenarios. If you try to memorize them, is it possible for you? It's definitely not possible for me. I'll be totally confused. Okay, but we need to understand the meaning, and then we reason. We understand the meaning and we reason through it. Okay, so any questions? No? Right, so these are the reasoning. These are the reasonings. These are the reasoning. So now I'm going to show you work. I'm going to show work. Solution. Okay, that's a think out loud. Okay, so if this is true, I will tell the reader this is true. Step 2. And next, I no longer have absolute value, so I multiply both sides by 3. Right? And in the end, my x equals to 4/5. And I'm done. Okay, so how do we read these lines? If this is true, then this is true. And if this is true, then this is true. And if this is true, then this is true. You finished. You finished. But there's much thinking. There's much thinking. And at the root of the thinking is what? At the root of the thinking is what? Is this. This piece tell us so much information. What does it tell us? Okay. What does it tell us? It tells us that, it also tells us the absolute value of anything less than 0, which is the opposite of it, is not possible. Doesn't it? So if this is always true, its opposite will never be true, isn't it?
Yes.
You see, every statement, if you understand that statement, there's the opposite side. Of course, that statement may be true or may not be true. You first have to say, is it true? If it is true, then the opposite will not be true, isn't it? And the implication, that what mathematics train us to do. It gave us some basic, thinking skills, logical thinking skills, really. Does it solve all the world's problem? Of course not. The world is way too complicated. It gave us some logical connection, which is vital. Okay, and what else does this imply? This implies this is larger than 0, or equal to 0, isn't it? And each one has its own implications. In this case, omega cannot be 0. It can be positive or negative. In this case, omega must be 0, right? You can see all those implications, right? You can see all these implications. So really, this sentence is very, very powerful. But how many of us do really understand it? A lot of people tell me, I understand, I got it. But they cannot do this question. And they cannot do, and then it cannot do 11, 12. They get confused. That means you didn't understand. Okay, so all of these questions really is testing you one thing and one thing only, this sentence. Do you really understand it? Okay, a lot of us, just like myself, when I was a student, I thought I understood, but I didn't. So don't just tell yourself, oh, I understand. Well, that's the beginning. The real test is after you start to work on some questions, you start to reflect on the lessons, then you say, what this is, that's what it means. And then you have to understand a little bit more. Okay. So our understanding of just like our understanding of the world is at different layers. Mathematics, of course, is no exception. For myself, and I believe for everyone. Okay, so be patient with ourselves. And let's take a break. Be patient with ourselves. Okay, that's part of loving ourselves, isn't it? Okay, take a break. Let's see what time is it. It's, oh my God, it's almost 11. How about we come back at 12? Okay, come back at 12. Back at 12. Okay, so I'm gonna. All right. How did it go? Do you think we understand a little bit better about these statements and its implications? Right? Be patient with ourselves. Okay, be very, very patient with ourselves. Okay, so what do you, the task you're taking on is not easy. It's not easy. Okay, it's not easy for everybody. Okay. I would take some more questions if you have any on 16A, and you would have another quiz later today about absolute value. Okay, about absolute value. Any questions?
No, I'm good, Professor.
Got it? Right, really, you start to think, right? You start to think, what is the implication, right? And this is the statement. If this statement true, if it is true, that means the opposite will not be true. And what's the implication of this state? Mathematics is a highly shorthanded notation language. Okay, there's a lot of shorthand notations. If you don't understand the notation, of course you don't understand it, right? If you don't understand the notation, don't even try to pretend you understand it. Just get to the bottom of it. What does it mean? What does this symbol means, right? Just like anything you do. I don't know how many of you are major, right? And I personally, I would say pretty ignorant about art, about music, right? Some of us are musicians, and I know very little about music. But you try to understand its meanings, right? And sometimes the meaning may be very straightforward. It's just how you feel, right? Like music. But in art, definitely there are symbols and meanings as well. If you don't understand the symbol, you don't understand the meanings, then you probably don't understand what the painter or what the artist is trying to convey, that message, right? But mathematics is more is clearer than that to me. Okay, and even though you may disagree with me because I don't understand art, because I don't understand much of art. Okay, I understand a little bit. Okay, very limited. But mathematics, the meaning of symbols has to be very, very clearly defined. That's the difference for me between math and the meaning of symbols in art. Because the symbol in meaning of art, I think in time it could change or evolve, and different ages, different time, it may have different meaning or connotation. But mathematics, the meaning, first of all, it has to be clearly defined, and secondly, it is consistent. It doesn't change. It hasn't changed in the last 200, 300 years, maybe even thousands of years, and it will not change in the next 10,000 years or beyond. Okay, so this is the to me that the meaning of symbols. All right, if you don't have any questions today, I actually would like to get started on the next one. We may still have to come back to revisit the absolute value after I grade your quiz. And I would like to take you guys to alpha 17. Okay. And for the remaining of the time, I'd like you guys to have paper pencil with you. And we're going to do some plotting and graphing. And we're going to have some observations. Okay. Are you guys ready? Where's everybody? Can you show your face? Hello?
We turn on our camera.
Could you turn on your camera? I want to see some smiley faces. Hello.
Hello.
Hi. Where's everybody else? I only see Marilyn. Where's Marcelo? Francisco? Stephen? I know some of you have a hard time. You may not have a camera, but if you do have a camera, could you just show your camera, you can show actually the camera, not a problem, because I have two screens. Okay, I have two screens. So it's not going to affect my typing unless it affects you. I don't know if that affects you. That's okay, Brianna. I'm sorry. Thank you for the effort. I just want to take a look is, how you guys are doing. I think the sun is out. Okay, the sun is out, which is good. All right. All right, guys. So next, today we're gonna do something. We're gonna start with something we're familiar with. Okay. Oops. What I'm thinking. What am I thinking? Okay, so let's get started on alpha 17. Okay. From this point on, we're going to be doing some quadratic. Okay, we're going to start a journey of quadratic. We will be spending quite a lot of time here. And we're going to be spending quite a lot of time here. Okay, but first of all, let's try to get familiar with these pictures. Okay, we have done this picture before, didn't we? Right? So we plotted the points. We plotted the points. And we know that this is the function for f of x equals to x squared. Right? We understand this picture. We understand this picture. But on 17, okay, we have graphed this picture. And we want to graph, we'll graph the other functions, the other quadratics in alpha 17. The first one is negative x squared. Okay, and then we're going to go on to do 2x squared. And then we're going to do half x squared. Have you guys done this before? Maybe not, right? Some of you have not done that. And then we're going to be doing this x squared. We're going to do x squared plus 1, x squared minus 1, right? And we're going to do more. And we're going to do x minus 1 squared. And we're going to do x plus 1 squared. Then you say, oh my God, what does this all mean? Inside, outside, it can be very confusing, isn't it? If you look at these expressions, right? What is this guy, what is this woman doing there? Do they look the same to you? I understand it can be very confusing. It can be very, very confusing. Okay, so we're going to do one at a time. One at a time. Okay, so for this function, okay, we did some time ago. Do we still remember how we did it? How did we do it? We see this as a function, right? And this function takes the input. And the rule of this function is that this is the rule. The moment you take the input, you multiply itself, you get the output. Right? We plotted the points before. So this is the output. And we understand this output is greater than or equal to 0 for any real number x. And that pretty much is speaking about the domain and range for this very specific function, right? And at the time we plotted the points, right? We plotted the points. We say, oh, f of -2, what would that be? I'm going to plug in. Right? And the input is -2. And we get that's equals to -2 times -2. And that equals to 4. Right, so let's review this. Okay, so I'm going to give you a couple more numbers for you to evaluate. F of -1 to see if you still remember. F of 0. F of 1. F of 2. Could you complete that? Okay, so this is just a recap. Okay, so what do we get here? For -1, this is going to be -1, and this is -1. This is -1. This is going to be +1, right? For 0, you're going to have 0 squared, and that's going to be 0. Right? And the input is 1. It's going to be 1 squared. It's going to be 1. And the 2 squared, that's going to be 4, right? And we make these points, okay? So we compose these points and input, output. Input is -2, output is 4. And this will make another point. And we put these points on the rectangular plane, right? And the next one, that's what we did, didn't we? And over here, and over there. So we made all of these points. You can see those points in the picture, didn't you? -2, 4, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay, we did that, right? Back, I think at alpha 4. Now we're gonna put these on the table. Okay? It's easier for transportation. It's still just another form of illustrating. This might be something you have seen before. Okay, this might be something you have seen before, so I'm going to increase the number of rows. Okay, so this time I will be arranging this table in such a way. Okay, in the function form, you know this input output, right? So input. Okay, there's a variety of ways of doing this. Input, output. Okay, and then this is the points. Input, comma, output. So input, okay, input will be -2, -1, 0, 1, 2, right? And output, what are the output? So I'm going to put these output out there, okay, systematically. You can see we do it systematically, okay, and we do it in a table form. We do a table form. Okay, does everybody follow me? Does everybody follow me? So f of 1. Okay, so have you guys seen some of these before? Yes? And of course the table can be longer, but we're not going to do that many. Okay, I'm sorry about that. So this is going to be 0, this is going to be 1, and this is going to be 4, and this is 1, and that is a 4. So we got these points. We got these points. So -2. So we're doing these repetitively. I hope everybody got it. You may have also noticed that I put these numbers, okay, I put these numbers in some special order. You see the input is from left to right. -2 smaller than -1, -1 smaller than 0, 0 smaller than 1, 1 smaller than 2. So I put in this order from smaller number to larger number. You follow me? So of course we have this curve. We have this curve plotted. Okay, so I'm going to put it right next to it. Now what are we going to do next? Okay. The next thing we do, does everybody follow me? Any questions? No questions? Okay. If you don't have any questions, the next curve we're hitting, we're going to work on this guy, -x squared. -x squared. Okay. It's a new function. It's a new function. I'm going to call it G. Doesn't matter what name you call it really, okay? Just make a distinction, -x squared, okay? So the function we used to have before is f of x equals to x squared, right? And we know how this function works. We know how this function works, right? We know how this function works. So now we have a new function. The difference between these two functions is that there's a negative sign in front of it. What does it mean? It actually means after you're done with this guy, we're going to continue. Okay, this function is called a make opposite. Okay, make opposite. What does it do? Just put a negative sign on this. So the output is going to be -x squared. So you still do your x squared, whatever you did, but now we're going to make a negative, make an opposite, okay? Because all of these are going to be non-negative, so after you make opposite, they're all going to be non-positive, right? non-negative turn into non-positive. So in the actual calculation from the table, okay, the actual calculation of the table, so this will be transformed. This table will be transformed. Okay, this is F. Let's see what happened with G. G of X. What happens? I'm going to put this away. That's for the F. Okay, so let me put it this way. Sorry, okay, hold on. I'm just going to make make it just a little bit more clearer. Okay. I'm going to put G here. And this is the F out. This is F input output. Now it's G. Okay, now it's G. For the same input, what do we get for G? G is opposite of F, right? For the output. So all of these, when we calculate G, what happens? G of -2 is equals to negative of -2 squared. Okay, how do we calculate that? And this negative sign and this negative sign, they do not combine. Do you follow me? They do not combine because we have to do, please excuse my dear Aunt Sally, we have to do exponent first. So this negative sign stays, and this piece will turn into -2 times -2. Do you guys follow me? So in the end, we get -4. Does everybody follow me? And next, I want you guys to work out G of -1, G of 0, G of 1, G of 2. Okay, these are the algebraic or arithmetic details. Any questions? Okay, so what do we get here? You're going to have a negative of -1 squared, right? So the negative sign has to stay outside, and you do -1 times -1, and it's going to be equals to -1. And the 0 is just straightforward. Okay, -0 squared equals to 0. And over here is the -1 squared. We don't need a parentheses here. It's going to be -1. And this is going to be -2 squared. It's -4. Note the difference. Okay, one is -2 squared, and the other one is this and that. Can you tell the differences? Can you tell the differences? Okay. Take these away. Are these two the same or different? Very different, isn't it? Are they very different? Absolutely. -2 squared, if you have a parentheses, okay, it meant this is the base and that's the exponent. The base is a -2, so -2 squared means that. -2 squared without parentheses, it meant -2 times 2. And of course, this guy, we have done it. Does everybody follow me? Does everybody follow me? You see that there are big differences, isn't it? The bottom line is that whenever you have parentheses, you have to do parentheses first. If the base, okay, if the base doesn't have parentheses, when there's no parentheses here, there's no parentheses here, and the power is only given to the immediate base, doesn't include that. So these two tends to confuse a lot of our students. Okay, I hope that clarifies it. Okay, that clarifies it. Okay, so of course this equals to 4 and this equals to -4 and this equals to -4. Okay, know the differences. Now, for this new function, -x squared, we are also going to compose the input output. Okay, so what will be the input output here? The input is -2. The output is a -4. Okay, I want you guys to compose all of these points for the new function g. Sorry, for the new function g. G function. Okay, g function. What you get? Okay, so this is, I'm going to put a f output, and this is going to be g output. Okay, just to make that distinction, f output, g output. F output, G output. For G output, -1, this is a -1. And this is 0, 0. And this is 1, -1. This is 2, -4. 2, -4. So let's look at the graph. Let's look at the graph. Let's look at the graph. We're going to graph it in the same picture. We're going to graph them in the same picture. We're going to graph them in the same picture. Okay. Would you like to get started or you want to watch me? I want you to get started first. Are you doing it? Okay, so I'm gonna do it. I'm just a little slower than you, but I'm coming. Are those dots you got? The new dots for G? I changed the color of the dots on F. So we can have some kind of contrast. Do you follow me? And when we connect these dots, what do we get? Okay. Now I want you guys to mark these points. 1, 2, 3, 4, 5. Mark these 4 points. 5 points, sorry. Please. I marked 1 as an example. Okay, that's what I want you to mark. Okay, decent. Okay, so 2 more to mark, 2 more to mark. Okay, everybody should mark your point, please. The last point is too squished. One more adjustment to make it just clear. Okay. Just 3. That should do it. Okay. So what do you see? This is x squared, and that's negative x squared. This is f, this is g, right? That's f, that's g. So one final mark. I'm gonna make this 2. That's gonna be 6 to see if that happens. So this is f. That's f. Okay. Last. Okay, I'm sorry. This is the last. G. G. We're gonna make it say negative 2. Negative. And then we're gonna make it red. Negative so g, f, g. So this is x squared, and this is a negative x squared. So what do we see here? It's a flip over, right? So the input, we can still be any real number, but the output are what? For the same input, the output are opposite. For the same input, the output are opposite. So it's a complete flip over. Do you follow me? It's a complete flip over. Now, what do we do next? 2x squared or half x squared, right? 2x squared or half x squared. Does everybody follow me? Okay, so next, we're gonna 2x squared, half x squared. And now I want you guys to do a table with me. Okay, we have to shorten the table a little bit, right? We cannot extend it forever. Okay, the F output. And this time my G let me insert a column. Okay, my G is going to be 2 times x squared. Okay. Same input. 2 times x squared. So what will happen? If we look from the perspective of function, right, instead of making opposite, what do? We double. Multiply by 2. Right? We do some doubling. And the doubling comes out as 2 times x squared. That's what happens. Okay, that's what happens. So that's the G. That's the G. Okay. Then what do we do? Of course, there's different perspective. You can, okay, you can totally just say, oh, I'm going to make a rule of the function. Really, there are different perspective. You can just say, okay, I'm just going to take 2 times the input. 2 times the input squared, and then 2x squared. That either way is fine, really. The perspective you see doesn't have to be unique. But the bottom line is that you have 2x squared and you double it. You double the outcome. You double the output. So what happens? What happens, right? For this input, what will be the output? Okay, suppose the input is -2. And this input is -1. And this, of course, is 0. Right? So let's see. Let's work on 2 times -2 squared. Everybody need to work on this, okay? So you won't be confused with those little details, algebraic details. There's a lot of algebraic details we need to be able to handle. Okay, so that's going to be 2 times 1 squared. And g of 2 is going to be 2 times 2 squared. So can you guys calculate those numbers? Could you guys calculate those numbers? And of course, we're going to compose input output. And this time is going to be G output. Okay. What is 2 times -2 squared? You had to do exponents first, right? You're going to do exponents first. So you're going to have 2 times -2 times -2 is -2 squared. So that's what you're doing. So in the end, you get what? What do you get?
8.
That's right. So the first point is going to be -2, 8. So can you finish the rest? Could you finish the rest of these? Any questions? So this is 2 times -1 times -1. And in the end, we get 2. So the second point is a -1, comma 2. And of course, that's a 0. And that's going to be 2. And that's going to be 8. Input output. G output. Well, we have some repetitive names, okay? I hope this doesn't confuse you. And we're gonna plot these points. We're gonna plot these points. And as a matter of fact, I'm gonna make a little adjustment here, okay? The F and G, I'm gonna use different names, okay? I'm gonna use slightly different names for the F and G. G, I'm gonna call it negative x squared. And the F is gonna be x squared. Okay, so for clarity. Okay, that's x squared, that's a negative x squared, okay? So that we don't get confused. Don't get confused. Now we're gonna continue the plotting. We're gonna continue the plotting. We're gonna put all of these points for 2x squared in the same picture. Could you guys do that for me? Could you guys do that for me? Okay, all of these points. Okay, negative 2, 8. And we're gonna choose a color, green, a dot. Okay, and next one, negative 1, 2, a green. 0, 0, dot, 1, 2, 2, 8. All these dots. What do you see? Two x squared in the green. In green. What do you see? The curve is narrower, right? Thinner. If we connect the dots, 2x squared with green. Do you see that? So let's mark it. Let's mark it. Two times x squared. I'm gonna put it at level 9. Green. Let's see if this will make it. Oh, we can scoot over a little bit. Okay, we can scoot it over just a little bit. Say 1.5. 1.75. All right. Not too bad, right? Not too bad. Now, we're going to do half x squared. We're going to do half x squared, okay? We may not be able to finish today, but I'm asking you to complete it after class. Okay, we did a double x squared, and now we're going to do half x squared. Okay, we're going to do half x squared. Okay, I'm going to ask you guys to complete this table. And this, instead of double, we're going to do half. No problem. We're going to have fractions. That's not a problem. We can deal with fractions. We can deal with decimals. No problem. Half. Okay, this is half. And of course, the number will have to be changed. Okay, this is going to be half. Half. And this is going to be half. All of these numbers will be adjusted. So this is going to be half. And this is going to be 2. And that's still 0. And this is going to be half. And that is going to be 2. So this is going to be 2 half. Does everybody follow me? Has it become easier? Am I behind you? It would be good if I'm behind you, okay? On Wednesday, we'll continue this, but let's finish this, okay? Half. We're gonna graph it in the same picture, but this time it's half x squared. And certainly we're gonna use a different color. And let's see what color we're gonna use. We're going to use this color. Oh, let's see how it looks. Is that good? What do you think of that color? Is it clear? The bright blue. What do you call that color? Turquoise? How do you like? Oh, it's called light blue green, whatever. So we're gonna add so that -1 is gonna be half the output, and 0, 0. We're almost there, okay? 1.5, 1 comma half, 1 more point, 2 comma 4. No, 2 comma 2. You guys see that? I'm sorry about the noise outside. So let's connect the dots. Let's connect the dots, which is a half of x squared. Okay, and we're gonna use that color there. And to mark it, it's a half of x squared. I'm gonna use a 0.5, 0.5 x squared. Okay, just to avoid any confusion. I'm going to put it over, where I'm gonna put it? I'm gonna have to put it at 2. And why is it 2 as well? Maybe 2.2. 2, 5. Okay. To hopefully let that color will match. Ah, that's not very clear. Hold on. How about that? 0.5 x squared. Do you guys see that? They're color coordinated. They're color coordinated. So this is the black one is x squared, 2x squared, half x squared, and negative x squared. Is that clear, everybody? I think that's all for today. That's just an introduction to quadratic. That was the introduction to quadratic. And we will continue. Okay, we will continue this process. We'll continue this process on Wednesday. And do expect another quiz on absolute value of inequalities. But I suggest you don't wait until the weekend and do as early as possible because I may not make this due over the weekend because I want to kind of recap the picture. I will try to give you enough time. How many people do work? Okay, I'll try to give you enough time. But if we cannot do it, I will give you enough time. But we will still have to come back to recap on the absolute value because I anticipate there might be issues. Okay, there might be issues. Okay, and homework today is you're gonna continue to you're gonna finish up the alpha 16 and the plot. Okay, plot all of these we've done in class all over again. Could you do that for me? Because right now you just write it down and you need to do it all over again. Okay, I will see you guys on Wednesday. Have a great day. The sun is out.
Thank you, Professor.
Thank you. Good job. Have a great day.
Thank you, likewise.